Hello, everyone. I hope you're doing well today. For those who just arrived, please feel free to type in your name in the chat box below, where you're from, and what company, university, or organization you're representing. Welcome to all. I hope you're having a great week so far. Again, good afternoon to all our participants. I am Emily from SuperMap, and I would like to acknowledge our host university, Visayas State University, and please say hi in our chat box, please, students and faculty of VSU. Thank you so much for being here. And to everyone here, it's my pleasure to welcome you to this webinar entitled SuperMap GIS Powered Platform for Transportation. This is in collaboration with the Visayas State University College of Engineering and Technology, the Department of Geodetic Engineering, with the CET Supreme Student Council, Geodetic Engineers of the Philippines VSU Student Chapter, Philippine Institute of Civil Engineers VSU Student Chapter, Computer Science Student Society, Junior Philippine Society of Mechanical Engineers VSU Student Chapter, and the Visayas State University Meteorological Society. To jumpstart our event for today, let us hear some opening remarks from Justin Jane L. Rebuyas, instructor from the Department of Geodetic Engineering in the Visayas State University. May I call on Ms. Justin?
Hello, good afternoon, everyone. Is my voice clear, ma'am?
Yes, ma'am. Thank you so much.
Thank you. Good afternoon, everyone. And I am glad that this webinar, we have this SuperMap GIS webinar with our partners. So in behalf of the Department of Geodetic Engineering here in Visayas State University, we are so thankful for our partners from SuperMap Philippines for creating this type of webinar to give valuable information to our students, to faculty members, and also from the industries who really use GIS on the daily basis or in their field of work. No? So although only few of the people nowadays know GIS, parang common na siya in our household, no? So we also encountered this GIS in our daily lives, like we navigate directions using our cell phones with GPS applications. We also see maps that are posted in the news showing trends of COVID diseases. So it's already part of our lives, no? And as we go back to the roots of GIS, diba, it was basically used to map the cholera outbreak, no, and to determine how it all started, no. So as we go on, or as the system evolved during time, and with the advent of computers, the applications of GIS has also expanded. So from basic mapping, surveying, we already use GIS in urban planning. We use GIS for natural resource mapping, for for transportation, like we are focusing right now, this afternoon's webinar. So I will not make this welcome address too long, because actually, as I received the letter from the SuperMap Philippines, I am very excited now, since it is for me, it has been a new technology now, a new part of the GIS community, and I'm so excited what this technology is in store for us, and to help develop and evolve the system itself. So again, on behalf of the Department of Geodetic Engineering, I officially welcome you to this webinar. SuperMap GIS as a platform for transportation. Thank you.
Thank you so much, Ma'am Justin. And I'd like to highlight what Ma'am said about GIS. Actually, contrary to common impression that geographic information systems are only used by the mapping industry or land surveying, it is now actually used in a lot of industries, including public health as well. In fact, the first known use of GIS is when John Snow wanted to map out the spread of the cholera outbreak. So that's actually an interesting trivia. So if you're here and you're not directly involved in an engineering field or any mapping or land surveying industry, you can actually still use GIS for sure in whatever field you are in. So I hope you get more inspiration as we go along in this webinar. Moving on to our topics, we are going to have two presentations. If you have any questions while listening to the speakers, please feel free to type it in the chat box below. The technical team will answer the questions in the Q&A session after the presentations. Our first topic is on how SuperMap boosts transportation, to be presented by Marife Belando from the Business Development Team of SuperMap Asia and Oceania Center.
Thank you, Miss Emily. So good day, everyone. I am Marife from the Business Development Team of SuperMap Asia and Oceania Center, Philippines. And today I'm going to present about how SuperMap boosts smart transportation. But first, let me give you a brief background about SuperMap GIS technology and company. So SuperMap was founded in 1997 by Dr. Ershen Zong, and we just celebrated our 24th year anniversary last Friday. So SuperMap is headquartered in Beijing with 38 branches and offices in mainland China, Hong Kong, and Japan. And as of now, we have 4,000 employees from all over the world. And we are happy to announce that we have some job opportunities available for you. We are also open for internship. So should you be interested, just visit our Facebook page, facebook.com/supermappgh, or email me directly at marife@supermap.com. So this is the China GIS market share in 2015. We can see from this chart that SuperMap became the top 1 GIS software provider in China in 2015. Also in 2019, SuperMap was able to climb as the top 1 GIS software provider in Asia. Shown here is the SuperMap partnership map. As you can see, SuperMap has already been promoted in the markets in South Korea, Indonesia, Malaysia, South Africa, and also some countries in Europe. And to date, SuperMap has about more than 700 partners from all over the world. Some of them you might be familiar with, like IBM, Microsoft, Huawei, among others. And SuperMap has also entered the Philippine market, and our business is still expanding. Connect with us through the emails that you see on your screen. So let's now proceed to the topic of today's presentation. So here is the outline. First is about how to construct basic transportation GIS application system. Next, we are going to learn about how to further construct a more complete system of transportation business, and we call it Transportation OneMap Platform. Then with the 3D technology development, we will talk about why transportation construction needs 3D technology and what 3D technology can do in transportation construction. And lastly, with the development of big data, we will discuss how we can integrate transportation construction with big data technology. So let's talk about the process of constructing basic transportation GIS system platform. First, let's take a look on why the system needs to be improved. There are a lot of businesses and applications that needs to be integrated in the system. Railway business, aviation business, travel service, post, logistics, and a lot others are all involved in transportation. Each of them has their own business requirements. So questions would be, how can we assist the industry in sharing and integrating spatial geographic information resources? How do we integrate the various business applications into one system? And how can we save the construction cost of industry spatial data management and improve the quality of data service and user experience? Now, let's see what are the challenges of transportation GIS. With more and more GIS data generated, one of the challenges that would be encountered would be how to manage, store, and update the increasing information. There's also a large number of repeated and decentralized spatial information. So how can we optimize it? In addition, there is a lack of unified standards for the management of space information and a lack of space information sharing mechanisms and technical means. And the last challenge is that with the development of Internet electronic map, how can we construct a system that is more professional, more reliable, and has more practical applications? So with these questions, we propose the IKW model to solve deepening industry application. It is a development mode from data to wisdom. In the traditional way, we always solve problems according to the data that we have, so we can only do a few applications. But if we further integrate this data, extract the valuable information, we can do much more applications. And the future development direction is to solve the more complex industry problems in a more intelligent way. With the new development modes, we propose Transportation OneMap, which can integrate transportation industrial spatial resource, provide application foundation of traffic and spatial information, and be a platform of spatial information sharing within the transportation industries. First, let's look at the system architecture of transportation service platform. All the system cannot be constructed without the hardware and software components. The second and most important layer is data management. Data is the soul of GIS. There are various data related with transportation, including spatial and non-spatial data. All this data need to be processed, classified, and stored based on a certain data standard. Different types of data need different storage. The next would be the kinds of services needed to be used for developing applications based on the requirements of the system. The basic applications of transportation GIS should realize road network management, traffic facilities management, statistics of various data, route design, navigation, and emergency reporting. We may need these services for functions such as map service, data service, and some analysis services such as network analysis and spatial query service. And the last layer is user layer. We need to know which terminal should be used and who will use the system. All these modules form a complete system. Next, we are going to further learn about how to construct a more complete system of transportation business. This picture shows how to realize information spatial splicing based on OneMap. The first level is City Department of Transport, which provides local transport thematic data, road network, and railway network. The second level is Province Department, which aggregate provincial traffic thematic data. The last level is National Department, which aggregate national traffic thematic data. Hence, the main idea of Transportation OneMap can be understood like this. The business information integration of each region can be spliced in space to achieve a complete picture. This vertical business integration and horizontal regional splicing spatial information framework is called OneMap. The steps to realize OneMap integration are data collection, information integration, service sharing, and finally, realize intelligent management through cloud technology. Based on these ideas, we have developed the open framework product of OneMap and formulated the standard system. The traditional mode is to develop a specific business for a requirement. This new platform integrates multiple industries into one system through a unified GIS management platform, which can effectively improve resource utilization and sharing. Now, let's look at what the platform should build. The content includes three aspects. We have standard construction, data construction, and system construction. First, let's discuss how to realize standard construction. There are three parts. We have management specification, data specification, and service specification. The core construction is data specification. This part mainly discusses how to standardize different types of data. For vector data, grid data, attribute, and other data, we need to standardize them, and then according to the data management method and core metadata standard of OneMap, we can establish the data classification system. The data classification system is divided into information service, graphic mode, and interface, and the respective specifications which are established to generate service sharing specifications. Further, the management specification can be established by creating data document specification and data backup specification so as to achieve OneMap standard system construction. The core is the process of converting data to service. So each industry has its set of data. We provide classified storage based on the data standard. Each industry data can be divided into general spatial data and industry private spatial data. And general spatial data can be integrated to one general and one traffic public spatial data. Finally, there are three types of databases. We have Transportation Geographic Information Data Platform, General Spatial Data, which store basic geographic data, and Traffic Public Spatial Data, which stores traffic thematic data and all the industry private spatial data. The next step is to realize the construction of transportation service platform after data classification. First, we need the user layer. We need to know who will use the services and what they want to do with the services. For example, business departments. They want to provide comprehensive functional services, integrate application system, and develop framework SDK. The decision-making departments want to realize spatial representation of data mining and spatial statistical analysis of traffic. The public needs detailed and accurate travel services as well as real-time traffic information. Therefore, we first need to publish static data as GIS general service to provide the basic functional services. Then, dynamic data is published as data or information publishing service, providing real-time services. We also need to publish data mining results as professional transportation services, providing statistical and analysis services. And finally, mutual support is realized through shared service platform. Through data management and service management, a OneMap system is built to realize the application to users and generate standard application services at the same time. Each level is based on its corresponding standards. The platform will form three types of service applications: map service, data service, and functional service. These applications can be obtained by accessing the platform. Each service corresponds to its functions to meet the requirement of different users. Now, let's look at how to integrate multi-source data in a system. We can integrate the spatial geographic data in a map by thematic map. Data for each category can be displayed on a map as a layer. Each layer can be controlled through layer management and scale. Facilities information is usually saved in the form of documents. GIS can realize visual management of facilities after symbolization and associate the attributes with the spatial information of facilities. Users can easily query the status and information of various facilities on the map and clearly understand the spatial distribution of them. GIS can realize spatial query and attribute query of all the spatial elements. The platform supports the input of keyword query and also supports the click of query element details on the map. The system can also provide the spatial statistical function of traffic thematic data and display it on the map in the form of thematic chart, such as the road length statistics, construction fund statistics, maintenance cost, traffic flow, and transport statistics, and many others. Network analysis is the basic analysis in GIS, which can realize path design of two locations and list all routes available. It can be the shortest route or the route that costs least travel time. With the mobile application development, route navigation between 2 points can be realized. For the problems found in the process of patrol inspection, professionals can input the detailed information, location, level, and other information of the problems through the mobile terminal for reporting. The reported issues are stored in a specialized database, which can be displayed and managed in the platform. The issue's maintenance status can be checked on the map. The red icons represent issues that have been submitted but not yet fixed. The yellow icons means the issues are still currently being solved, and the green icons indicates that the problems have been solved and passed acceptance. Users can also check the details of every event. For emergencies, GPS is used to locate the incident. Users can quickly fill in the information, assist multimedia means such as photographing, hand drawing, audio, and others to clearly display the site status so as to realize real-time report based on mobile network. Here, let's look at the case of OneMap Application. This is OneMap platform of Jiangsu Province Transportation. The homepage integrates with data sharing, service management, and public information publishing module, and provides application interfaces of Resource Center, Development Center, Map Center, and Application Center. All business applications are integrated into the Application Center, including road application, railway application, airport application, public traffic, port application, and so on. The second case is Traffic Emergency Command Platform of Xinjiang. This system not only integrates information sharing and applications, but also provides emergency reporting and handling, as well as command and dispatching. The Transportation OneMap is already a complete platform. The next we are going to talk about is how to optimize transportation construction with 3D technology. So why do we need 3D technology? At present, many 3D entities have been formed in the main roads, bridges, tunnels, and culverts, especially the main connecting lines, and roads around the city are mostly complex overpasses, and we lack effective 3D display means. Traditional maintenance is mostly based on the management and application of 2D plane vector data, lacking the ability to restore the terrain around the road to 3D scene, and cooperate with emergency rescue to develop an overall solution. Hence, we need 3D technology to display the 3D entities and make an overall solution with 3D analysis. Let's look at how a 3D GIS assists transportation construction. First, 3D GIS provides better visualization of reality scene. We can view the sky, the objects on the ground, even objects underground at the same time. It can also solve practical problems such as the height design of overpass and display interior space such as the tunnel mode at the same time. 3D technology makes also intelligent scene as possible. You may wonder what kinds of 3D model are supported by SuperMap. So listed here are some main 3D models like oblique photography model, BIM, point cloud, 3D terrain, fine model, and others, which are all supported to integrate with SuperMap GIS. The way to match multi-source 3D data is by converting 3D model to a format where GIS tool is accessible. The model integrity, attributes, and consistency between graph and model need to be ensured after data fusion. Each model is added to the scene as a layer. Here, let's see some cases of the 3D model fusion. The first one is the integration of 2D vector line with oblique photography by 3D symbolization. So let's look at the video of how it was done. So this is the integration of 2D vector line with oblique photography by 3D symbolization. Next, we also have the integration of 3D model of professional modeling software and GIS. So this video shows the integration of BIM with oblique photography, 3D terrain image, and other geographic data. The status of the viaduct under construction and the worksite, as well as the terrain around it, is vividly displayed. 3D GIS also provides many analysis functions. There are 4 operations. The first one is 3D spatial expression, which not only display the realistic object, but also the shadow body, visible body, skyline, and others. The second is 3D functional operation, which includes spatial operation and spatial relation judging, spatial analysis, and 3D measurement. For 3D export, data can be converted to 2D and can realize 3D print as well as volume computing. Customized development is also supported with WebGL. Here are the results of 3D analysis. We have for 3D slope and aspect analysis, for profile analysis, 3D isoline analysis, and 3D buffer analysis. The minimum vertical clearance often needs to be ensured in the design stage. The 3D model can well display and measure the value. The tunnel body model is built by convex hull, and the spatial operation between convex hull and mountain is realized to dig the tunnel. Three-dimensional analysis can realize some 3D spatial relationship queries and judge the relationship between two spatial entities, including contain, disjoint, overlap, and intersection. So this example shows the intersection results of subway and building. The buildings that intersect the subway are highlighted in the display. In the practical application of integrated 2D and 3D technology, the system can display 2D and 3D integration scene and view the overall status with 2D view. Meanwhile, display core construction scenes with 3D model monitor the construction status, check risk sources, query, and highlight the risk sources. In the mobile terminal, we can realize 2D and 3D integrated visualization and 2D and 3D integrated navigation, as well as indoor and outdoor integrated navigation. Finally, let's look at the application of big data in traffic development. First, we need to briefly know what constitutes the big data GIS technology system. Cross-platform GIS and cloud GIS are the basic technology of big data GIS. The core technologies of SuperMap Big Data are big data storage management, distributed analysis, stream data, and big data visualization. So we already know the diversity of traffic data sources, but we also need to know how to store the growing amount of basic geographic data and thematic data and how to display them high efficiently. SuperMap provides SDE, web engine, and multiple distributed SDX to solve the storage issue of big data. Let's take a look at the result of 450 million line data based on H-based storage. It is displayed smoothly in the system, as you can see on your screen. Big data analysis operators based on SuperMap and Spark are growing. SuperMap provides different analysis operators for 4 different types of data. Based on these analysis operators, the results of big data analysis can be displayed in the deeper level. Like OD analysis, and the principle of OD analysis is to mine and analyze the starting and ending points of traffic and the connection degree between stations from big data. The video shows the comparison of morning and evening peak flow between 2 subway stations of Beijing. It is planned to build a road across the whole area, and all influenced land parcels need to be identified. This example shows the display of large number of land parcels with 10 distributed clusters. Then buffer analysis and overlay analysis were done to calculate the occupied land parcels, which only takes less than 45 seconds. Integrated with IoT technology or Internet of Things, Big Data GIS can realize real-time monitoring through streaming data service and distributed service, as well as big data analysis. In this example, real-time query of road conditions is realized based on distributed storage and big data analysis by accessing real-time traffic flow data. This video shows the statistics of taxis get-off points in the evening rush hour based on big data hotspots analysis based on taxi data, analyze contact degree of each district and county, where the population input and the population outflow areas were. And lastly, this video shows the number of global airplanes in a certain period of time based on big data aggregation analysis. So that concludes my presentation. Thank you so much for your attention.
Thank you so much, Marife. Pretty cool, right? That was just a sneak peek of the applications that can be done with the SuperMap GIS technology to boost transportation. While you're letting all of that sink in, maybe you can also start pondering on how you can utilize this kind of technology, not just in transportation applications, but also in your field or industry. Like I said before, GIS can be applied not just to very technical fields, but also in any other application that you can think of that requires locational analysis. We're excited to hear about what you come up with, and we're very open to collaborating with you to make that happen. Again, if you have questions about what Marife just presented, please head to the Q&A chat box and our technical team will answer them. At this point, let us have a quick 3-minute break. Meanwhile, kindly fill up the form for your certificates flashed on the screen and linked in the chat box below so we can generate your e-certificates for this event. The form will only be open until the end of this webinar. So you can have your 3-minute break right now, do a stretch, maybe go to the bathroom, get some water, and don't forget to fill out this form. Thank you. All right, so let us continue our program. For our second and last topic, Erica Jane David from the Business Development Team of SuperMap Asia and Oceania Center will be presenting to us about SuperMap GIS for fleet management.
So good afternoon, everyone. I am Erica from the Business Development Team of SuperMap Asia and Oceania Center. And I will continue the discussion about SuperMap in transportation, specifically on fleet management. So fleet management system generates vital data in a graphic form, making it easier to comprehend for the customers, drivers, operators, and tourists. With this, we can access real-time information like vehicle position, emergency situations, traffic violation, and others. So let's take a look at the function structure. The ones on the top portion introduce the functions that the system can provide. We have project status monitoring, emergency management, vehicle scheduling, attendance management, speed alarm, vehicle monitoring, and track playback. With these functions, we can provide SMS information from the platform to mobile terminals. We can also do basic map management with the geospatial data available. Automobile GPS and handheld GPS can be used for real-time information collection of data. This data can be used for monitoring and web services and will constitute the basic business data on which we can base some information management. To understand better, let us look at the system architecture. At the bottom, we have the device layer, which is used for collecting the GPS data. Then the data can be uploaded into the system by these two services and stored into the database. We can use the collected data to create the base map and do basic data management. Next is this is the support function layer. And finally, we can achieve the business functions. The business function layer is the main goal of the system. In addition, the system is integrated with Spark technology, and the platforms that we use are SuperMap iServer, iClient, and iDesktop, which supports and develops different functions for business. So next, I will be showing you the key technologies of SuperMap. We summarize the 5 key technologies of SuperMap as BitDC. We have the Big Data GIS, AI GIS, 3D GIS, Distributed GIS, and Cross-Platform GIS. Later on, I will be focusing on Big Data, which is the technology that helps in managing the many sources of data of the system. So this is our product system provided by SuperMap. It can be divided into 3 parts: the cloud side, edge side, and terminal side. On the cloud side, we have the iServer as a server application to publish our spatial data and GIS capability. The iPortal helps us to easily create our own GIS portal. iManager is for operation and maintenance. On the edge side, we have the iEdge, which can help us enhance the performance when the network is not good. On the terminal side, we have the Terminal GIS for desktop, the iDesktop, and iDesktop X. And the Terminal GIS for components, they are iObjects for different coding languages such as C++, Python, and Java, and new technology for blockchain and Scene SDKs for game engine. We have the iMobile and iTablet, and under web, we have the iClient for JavaScript, mainly for 2D, and WebGL for 3D. So now let's talk about Big Data GIS technology, which is also related to the Spark technologies mentioned previously. As we know, data gathered for analysis can amount to millions, and it has been a challenge for us in how we can achieve an efficient data management, analysis, data processing, and visualization. SuperMap has the high ability to handle big amount of data with big data storage and with the help of distributed GIS operators. SuperMap supports many big data algorithms using Spark Calculating Frame, like spatial big data analysis, streaming data, and spatial machine learning. We have more than 60 in total, and all these algorithms can be used in the distributed environment. One spatial analysis operator is geofence, which is the real-time dynamic determination of which targets fall into the selected fence, with support for calculation of enter, hold, exit, and other detailed state. We can use this for air traffic control center, cash truck, oil tanker, and other targets for real-time monitoring and fence border. So here is an example of distributed analysis operator geofence using data from airplanes. We can use SuperMap iServer streaming service to access the data from various sensors, such as from IoT or Internet of Things devices, and store this data to the data store for further application. Data gathered and stored in here are real-time and realized in different user platforms such as desktop, mobile, and web application. The streaming data service also rely on the IoT perception layer. So not everyone has a big data platform, and this might be a concern, but there's no need to worry about having no big data platform because SuperMap iServer has built-in Spark computing technology so it can achieve the big data application. With those who already have the platform, we can integrate with their existing platform since SuperMap supports direct integration. Now, let's go to the multi-terminal visualization of the system. Based on distributed data computation, we can visualize and store our data in different terminals. For the desktop side, we can use iDesktop X, which can handle data management, mapping, service release, and managing real-time data. For the web application, we can use iClient to develop the system, and iPortal, which provides no-code web apps such as DataVis, Map Dashboard, and Data Insights. And lastly, we have the iMobile, and I will be briefly discussing each terminal. First is about desktop. Distributed storage for spatial big data can be achieved by SuperMap iDesktop with different methods. You can use a command line, build API, or service interface to collect the spatial big data and distributed storage. So this shows some of the iDesktop X data management capabilities. We can view the maps, filter the attributes, do spatial query, and many others. These are some results based on the mapping capabilities of SuperMap iDesktop. We can produce well-detailed unique value map, label maps, digital elevation models, and others. This is an example of streaming real-time data of transportation in Hunan province, a transportation system built using iDesktop X to reflect the current traffic situation. In the middle is a map of Hunan province. So this system uses the aggregation analysis of big data to show the traffic situation. The left portion shows the traffic flow charts. This chart shows the number of cars for each city. The right portion shows the statistics of traffic information of each city and real-time monitoring video. With all this information, we can easily know which areas have high traffic. Going back to the center map, you can notice the numbers in each area of the province. The bigger the number is, the worse the traffic jam situation. Next part is a capability of iServer, which is the map service release. We can publish the map to the web using SuperMap iServer. With that, we now move on to the visualization on web terminals. We can do the web development, and with high performance distributed dynamic rendering, we can release massive data without slicing. The map can be browsed normally before the download is completed or while the page is loading, which greatly improves user experience. We have the iClient for custom development. And with SuperMap iClient, we can achieve these functions: big data aggregation operation, trajectory monitoring, also airplane check. These results can be displayed using static geographic visualization effects such as honeycomb map, origin destination map, and route map. From static visualization to dynamic, we support a variety of dynamic visualization effects such as strong boundary map, dynamic OD map, trajectory map, etc. We can do migration effect and others by iClient. Furthermore, we can do advanced visualization of geographic and streaming data, such as combining with statistics. With SuperMap iPortal, we can easily upload and register the data from the users and then do the analysis, management, and result release in iPortal. We can further make our own dashboard using no-code web apps such as DataVis and Map Dashboard to present the result. Here we have the no-code web apps. First is DataVis, which you can use to make thematic maps with static or streaming data. Data Insights is useful for displaying and managing reports containing maps and charts. 3D Earth is good for visualizing real space and 3D symbols such as streetlights, roads, water surface, and trees. Map Dashboard is where you can combine maps and statistical results in the large screen. We also give you some templates for Map Dashboard. It is good for monitoring, and the result can be adapted to different terminals. So you can access all of these through SuperMap Online. In SuperMap iServer, we have streaming service for our data. We can register and store data to the data store and visualize and access them in the iPortal. Different types of big data analysis can be achieved with this, such as OD analysis, density analysis, and others. At the same time, you can create and access thematic maps, hotspot maps, and many more. And here is a video of how to make a migration map or trajectory map with database of iPortal. You can configure how to visualize the data analysis or process, then publish it as a service. Here is another demo for database. As you can see, you can create your own dashboard. You just drag and drop and without coding. SuperMap iPortal also has data insights capabilities. So this is a map dashboard made with iPortal. It is a real-time monitoring platform for airplanes. The large screen can display more attribute information such as flight mileage, aviation punctuality, and other information, and understand the real-time information of national flights at a glance. Here is a demo using data insights to manage and produce reports containing maps and charts. Next is the mobile terminal. We can also display the big data operators like density analysis and aggregation analysis on our mobile terminals with the distributed analysis service released by iServer, which follows the process of mobile terminal requests, server generation, mobile terminal display. It gives full play to the advantages of mobile devices, getting rid of space constraints and grasp the analysis results at any time. Supported analysis models include aggregation analysis, buffer analysis, density analysis, element connection, grid index, overlay analysis, single object query, area summary, topology check, vector clipping, and many more. We can visualize streaming data in our mobile. Here we show the taxi application and the real-time location of the taxis. We can achieve the hotspot map or aggregation map and origin destination map and other spatial big data operator results in the mobile terminal. We move on to the next part of our presentation, which is the system function. Here is sample of the main interface of the system. The left part displays the web terminal and the right is that of the mobile terminal. With vehicle position monitoring, we can check the vehicle details including the car's ID, average speed, and their position. We can filter which data or vehicle to show in the map and get their position information. Next is track playback. We can use this to check the real-time information of the vehicles. The system can check the trajectory of each vehicle and show the route the vehicle has traversed over time. This one shows the creation of a scheduling plan from Monday to Sunday. So this is useful for planning and dispatching of the vehicles. Next, we can also check and display statistics such as attendance data for each vehicle. We can also monitor the distance they have traveled, oil consumption, and average speed. We can also set alarms for specified road sections if the vehicle exceeds the speed limit for that area. We can specify the section by setting the start station to end station. We can select the vehicle to inspect and see how long the vehicle exceeded the speed limit for that specific area. If the vehicle speed is more than a certain speed or specified parameters, it will trigger an alarm on the system. We also have emergency management. We can report the emergency by mobile and the situation or information will be uploaded to the system showing the emergency information, time, who reported the emergency event, the mobile number, and if the emergency is still ongoing. As I said, we can report events through mobile terminals and also access the current information or status, such as whether the operations or situation is back to normal, suspended, or under maintenance. Fleet management can still further be developed and used in other fields. So here are some application extensions. We can use this system in the mine industry to monitor the mining vehicles and the mine resources. It can also be used to for public transport to upgrade our transportation services and to reach the optimal use of the fleet, and then tracking vessels for maritime purposes. So lastly, I am going to present to you some technical solutions and case applications. Here is a demo for transportation application showing the streaming data trajectory construction based on the world's 2.5 billion record flight 4D data. Here is a big data platform in Nanjing with geofence function, aggregation operators, hotspot analysis to see which areas have high traffic, and monitoring migration trajectory of airplanes. The platform can manage trains, cars, and airplane data. So this is also used for public security and emergency management, as it can monitor and track patrol vehicles. For the last application, this is a satellite monitoring and tracking ship project. In a ship big data project, users' requirements include maintaining real-time location data storage and spatial visualization of 2.8 million ships per day, realizing efficient storage and custom query of the existing data, which includes 10 billion records, segmenting ship data, which is about 1.6 billion in half a year by day or hour, and reconstructing tracks within the time range. In response to the above requirements, SuperMap provides a solution based on streaming data storage technology, streaming data calculation technology, and streaming data visualization technology, realizing real-time monitoring of ship data, reconstruct tracks, and other functions. So that's all for my presentation. Thank you so much for listening.
Thank you so much, Erica, for sharing with us the overview and demonstration of SuperMap GIS for fleet management. There we have it. Our speakers just gave us a comprehensive introduction to SuperMap GIS powered platform for transportation. We hope that by this time it is bringing you some new ideas on your current projects, research, or business. So while the presentations were ongoing, you were sending in your questions, and we would like to call on our technical speakers to answer those questions.
Hi, good afternoon. So one of our questions is SuperMap GIS available for Mac OS? So SuperMap has desktop products which supports cross-platforms such as Windows, Linux, and others. So far, the desktop products don't support Mac OS. However, SuperMap has mobile products which support both Android and iOS. So just go to your Play Store. Another one, hello, where can we access the 3-month free use of latest SuperMap desktop version? So kindly email us at supermap@gmail.com. So we can send you the link for the downloading of SuperMap iDesktop. So it will be an advanced version with all extensions included. Also, are there manuals for the said version? Yes, the downloadable materials include manual through our help document. Another one, I think SuperMap is amazing, but looking for resources in the English language is a challenge, in particular for user manuals. Thank you so much. Yes, we think that it's amazing too. And also we have English version of the software is available in different languages, and one of which is English version. And don't worry about the trainings, because we do provide trainings in this language also. So follow our Facebook page and the SuperMap Philippines and SuperMap Facebook page to know about our ongoing trainings and webinars. So another one, will you be sending the recording? Yes, it will be emailed to you later after the webinar. So thank you so much.
Thank you so much, Martha, for answering their questions. And thank you to our participants for showing your curiosity about the SuperMap technology and today's presentations. If you would like to ask more, feel free to send us a message through these channels. So please feel free to follow us on Facebook, LinkedIn, Twitter, and watch our YouTube channel for more videos on more topics. All right, so again, this webinar is in collaboration with the Visayas State University, College of Engineering and Technology, the Department of Geodetic Engineering, with the CET Supreme Student Council, Geodetic Engineers of the Philippines, VSU Student Chapter, Philippine Institute of Civil Engineers, VSU Student Chapter, Computer Science Student Society, Junior Philippine Society of Mechanical Engineers, VSU Student Chapter, and the Visayas State University Meteorological Society. We hope that this webinar has sparked your curiosity about SuperMap and even the transportation industry, because we are happy to announce that we will be offering a free trial license to our participants here, just like Marife mentioned earlier. Just send us a message or an email, as you can see on this slide. To cap off our event for today, let us hear some closing remarks from Likha Montenegro, Student Council President of the College of Engineering and Technology.
Good day, everyone. On behalf of the Visayas State University, as a co-host of this webinar, I would like to express my warm gratitude to the people who made this event possible, especially to the team of SuperMap GIS Philippines, to our beloved host, Ms. Emily, and our technical teacher, Ms. Marifa and Ms. Erica. Thank you for bringing this opportunity to us by educating and promoting the use of GIS technology as a powered platform for transportation. I would also like to thank the people who participated and are with us right now. Students and faculty from Visayas State University, GIS enthusiasts across the Philippines and other countries, thank you for giving the interest and time to learn about SuperMap GIS. I hope that what you learned today about this kind of technology will develop your passion in the use of GIS, not just as a platform for transportation, but to other fields as well, to solve existing local and international problems and apply it in your careers in life. Once again, thank you, everyone. May your passion for learning keep on burning.
Thank you so much, Likha, and thank you, everyone. We highly appreciate your attendance today. Feel free to visit the SuperMap website to get more information about the company. We also invite you to follow SuperMap GIS on Facebook, Twitter, and LinkedIn, because we are constantly posting about the latest GIS trends and what SuperMap is currently up to. For the students, again, we are inviting you to join SuperMap's first ever local GIS contest in the country, Tagisan. You might also be interested to become one of our university ambassadors. You will become part of the SuperMap team, wherein you will represent your university. More benefits are indicated on our Facebook page, so make sure to like and follow SuperMap Philippines. Again, thank you for attending this webinar, everyone. Don't forget to answer the evaluation form, which you can find in the chat box, so we can bring you a more improved webinar experience in the following months. Expect your certificates within a few days via email. SuperMap will hold more webinars on more topics soon, and even more events. And we hope to collaborate with more universities in the Philippines, and of course, collaborate with Visayas State University again. We will virtually see you soon in the next webinar. Goodbye and have a great week.